for every unit, you have an abbreviation. So for grams, it's G. For moles, it's MOL. Never write M because that's meters. It's always MOL. Or you can write out moles. That's fine too. But MOL always means moles. So if we want if we're going to look at 3.5 moles of H2O and we want to know how many molecules that is, we're just going to do a conversion factor. So we're going to start with the 3.5 moles H2O, and then 1 mole of H2O equals 6.02 times 10 to the 23rd H2O molecules. And so make sure you distinguish between molecules and moles. I always use molec if I want to abbreviate molecules, just so they know that it's, that it's not just mole, it's molecules. So then if you do that math, 3.5 times 6.02 times 10 to the 23rd, once again, use your exponent button on your calculator. It's really going to help you in this section. We would get an answer of 2.1 times 10 to the 24th molecules of H2O. And now we can also go the other direction, where we start with a certain amount of atoms or molecules, and we figure out how many moles that is. So how many moles of Ag, silver, contain 1.1 times 10 to the 22 atoms? So before we start this, are we going to end up with an answer that is greater than 1 mole or less than 1 mole? Less. Why is it going to be less? Yeah, so we're trying to find how many moles, and 1 mole is times 10 to the 23. So if we have 10 to the 22 atoms, it's going to be less than a mole. So you're going to want to make sure that your answer makes sense. 1.1 times 10 to the 22nd atoms. Yeah. So it will be a fraction of a mole, exactly. And now 6.02 times 10 to the 23rd atoms per 1 mole Ag. So because you're dividing a smaller number by a larger number, it's going to be a fraction of a mole, and you get 0.018 moles of Ag. Exactly. Yeah. So if you're asking how many bigger things and a smaller thing, the answer is going to be less than 1. So these are the one-step versions of the problems, and then you can also use your molar ratio to take it an extra step. So I want to know how many atoms in 4.0 moles of H2O. Okay, so if we have moles of H2O, that means 6.02 times 10 to the 23rd molecules, and each of those molecules has a certain number of atoms. Okay, so we're going to have to go from moles to molecules to atoms. And I can draw that out: moles, molecules, atoms. So 4.0 moles of H2O. It's very important that you write moles of what? Moles of H2O, moles of silver, moles of sugar, because we're going to be doing these conversions that actually require you to distinguish between moles of one thing and moles of another thing. So we'll always say moles of what? So I say moles of H2O, and 1 mole of H2O has how many moles of atoms? 3. So every mole of H2O has 2 moles of H and 1 mole of O. So it's going to have 3 moles of atoms total. And then we use our 6.02 times 10 to the 23rd atoms. And your answer would be, sorry, I'm running out of room, 7.2 times 10 to the 24th atoms. That's a 4, 24. Any questions thus far? Yeah. So you have to look at the formula, right? You have to identify how many atoms you have in H2O. So in the formula, it's going to depend on the molecule you're looking at. So here you have 2 H's plus 1 O, so 3 moles of atoms total. Okay, so you have to add it up. Yeah.
I think the confusion is because you said your solution has to go from moles to molecules to atoms as well.
Oh yeah.
Yeah. In your solution map.
Oh, I did. I meant I was going to go from moles. Yeah, that is confusing. That is wrong. I went from moles of H2O to moles of atoms to atoms. Yeah, my map was wrong. This is correct. Yeah, thank you for pointing that out. Yeah, so moles. So if I ask specifically for hydrogen, you do moles of H, but in this case, I'm doing moles of H and O. Okay, I have a practice one for you. Yeah. Sorry, what was that? Yeah, I went from moles of atoms, and then 1 mole has 6.02 times 10. 1 mole of atoms has 6.02 times 10 to the 23rd atoms.
Yeah, but you can cancel it out.
Yeah. What would be on the bottom? No.
If you have it written down as 1 mole of atoms, it's equal to atoms. Then you can see it's
Yeah.
for sure. She put it in the middle so it can be seen for both.
Yeah. See, the atoms applied to both.
Oh.
Yeah. All right. Let's have you practice. Okay, I want you to practice this. Start with the 1.6 moles of C2H4 and find out how many hydrogen atoms, just hydrogen atoms, are in that many moles of C2H4. And yeah, so Okay, thank you. Yeah, they're not long. We'll use this one.
I just was like,
Yeah, this is much sturdier.
so I didn't.
Yeah, no. I'll use the other One point six. Just hydrogen atoms. So I did an example with all atoms. You're just doing hydrogen atoms. H. Okay. I'm gonna go over this. Oh, does everybody also know what 6.02 times 10 to the 23rd is called? What that number is called? Okay, good. I always forget to say that. Avogadro. Some guy named Avogadro figured out that number. All right. How are we going to start this problem? Shh. Okay, we start with 1.6 moles of C2H4. And what is my molar ratio of H to C2H4? 4 moles of H over 1 mole of C2H4. So you can write it since we're just talking about H and we know this is an element, we're going to go to atoms. You can just write 4 moles of H. And then what's our last step? 6.02 times 10 to the 23rd H atoms per 1 mole of H. And you should have gotten 3.9 times 10 to the 24th. And sig figs are still important, just so you know. 24th. Huh? So, no, but it's best for you. He just asked if I take points for not including conversions in the calculation, like on a test, if you didn't write like out moles of C2H4 and you just put 1 on the bottom. I wouldn't take off points, but I highly recommend that you keep it in because, and honestly, if you get it wrong, having more information, once again, it gives you more likely to get more points. But no, I will not take out points if you get the right answer and you just have ratios there. Using molar mass as a conversion factor. Katie, we're moving on. So can we, okay, thank you. All right, using molar mass as a conversion factor. Okay. So I could ask you how many moles in 9.75 grams of carbon. What's going to be your conversion factor? Molar mass. What's the molar mass of carbon? 12.01? What? Grams per mole. So 12.01 grams per 1 mole. So if we start with 9.75 grams of carbon, and we go from, so we're going to have to put grams on the bottom because we're finding out how many moles. 12.01 grams per 1 mole of carbon. And that will give you 0.812 moles of carbon, which makes sense because 9.75 is less than 12.01, so you're going to expect to have less moles because each mole is equal to 12.05. So it's going to be less than 1 mole. So then we could go further than that and we say how many atoms are in this mass. So how many atoms in 0.58 grams of carbon? So our unit map, our conversion map is going to look like gram. We're going to start with grams, and then we're going to go to moles, and then we're going to go to atoms. Moles are like, they're like your train station. You can get to almost anywhere from a mole because grams per mole, you have that ratio for every element. And then you have atoms per mole, which is a 6.02, or molecules per mole. So use moles if you're going from one amount related to a particular molecule or compound, such as grams, to another, such as atoms. Okay, so if you're going from grams to atoms, grams to molecules, vice versa, you have to go through moles. So we're going to start with 0.58 grams of carbon. We're going to use our molar mass again, 12.01 grams of carbon per 1 mole of carbon. And now we go to atoms by saying 1 mole of carbon has 6.02 times 10 to the 23rd atoms of carbon. And that's going to give you 2.9 times 10 to the 22 atoms of carbon. Which makes sense because you started with a pretty low amount of grams, right? You started with 0.58, which is a couple of orders of magnitude smaller than 12.01. So it's a pretty small amount. So you're going to have a relatively small amount of, it's not going to be a full mole of carbon atoms. It's less than a mole. Any questions thus far? Do you think you could go in the opposite direction on your own, or do you want me to do it? Okay. I'll do it. Okay, let's do an example going in the opposite direction. I could ask a question. Does everybody have this down? Okay, I'll give you a minute. Yeah. You should definitely always have your periodic table out from now on when you were in class because you're going to have to be using these masses. So definitely have that out to help you with these problems. because I can't read that. I don't have my glasses, but I don't think I can read it with my glasses anyway. Like, I can read the symbols, just not the anything else. All right, let's go in the opposite direction. How many grams do 2.45 times 10 to the 21 oxygen atoms weigh? Let's start with a unit math. What unit am I going to start with? Atoms, because that's what I give you. And what unit do we want to end up with? How are we going to get there? Moles. So we're going to go from atoms of oxygen to moles of oxygen to grams of oxygen. So I'm going to start with 2.45 times 10 to the 21 oxygen atoms. How do I get there from, how do I get to moles from atoms? 6.02, Avogadro's number. So I put, so since I'm going from atoms to mole, 1 mole of oxygen is equal to 6.02 times 10 to the 23rd. That is a 2, not a 1, 23rd oxygen atoms. And then what's my last step? It's a 1 mole of oxygen. 1 mole. I just made it worse. What do I use to get from moles to grams? Molar mass, which is 16 grams per mole. 16.00 grams of oxygen per mole of oxygen. And I get 0.0651 grams of oxygen. Does this make sense? Can anyone tell me why this does or does not make sense? Yes. He said the atoms are less than a mole. The amount of atoms we started with is less than a mole of atoms. So our mass is going to be less than a molar mass of oxygen. Any questions? Okay, let's do even one more step. I just want to check one thing. Yeah. Yeah. Oh, and molar masses do affect sig figs. Okay? So if you had, for example, 1.01 for hydrogen and everything else was 4, you'd have 3 sig figs or vice versa. So your sig figs are affected by your molar mass. Your molar ratio is an exact ratio, so it does not affect. So for example, the when we did 4 H atoms for every CH4, that's a molar ratio. It's an exact ratio. It does not affect. Okay, let's do how many H atoms in 2.6 grams of NH3. So now we're going from grams of a compound to moles of a compound, to moles of an element, to atoms of an element. So this is why we're talking about we have to use moles of what? Because we're going to go from moles of NH3 to moles of hydrogen. Sorry, no, we're going from grams of NH3. Forgot that first step. Grams of NH3 to moles of NH3 to moles of hydrogen to atoms of hydrogen. Okay. So we're going to start with 2.6 grams NH3. But what do we need to know to get to moles of NH3? Molar mass, which we have to add up from the periodic table. So can anyone add up for me the molar mass of NH3? Yes, 17 point what? 17.04 about, yeah. So it's 17.04 grams of NH3 per mole of NH3. What's our ratio in the next step? Yeah, so 1 mole of NH3 and 3 moles of H. And now we can use Avogadro's number to go from moles of H to atoms of H. Questions? Concerns? Yeah, and definitely, if you can double check to make sure when you put this in your calculator that you're getting the same answers I am. Even if you don't have time to do it right now, if you go home, run through my calculations and just make sure that you know how to use your calculator using that that exponent button, or making sure all your parentheses are in the right place. It's really important, because the last thing I want is you to lose points because you're not used to putting these kind of things into your calculator. I would like you to do one. It is not exactly like what we just did, so you're going to have to figure it out a little. We're going to be here to help you. I would write out your unit map first. How many grams of C6H12 contain 9.2 times 10 to the 23rd carbon atoms? What are you going to start with? Atoms. What are you going to end with? Okay. Knowing that, have at it. So don't forget the step where you have to go from moles of carbon to moles of C6H12. You need that molar ratio. Yeah. So you have to go each step.
Because you have a more C6H12. So, how many carbon atoms? So there's 6 more for carbon, and 1 yeah. Exactly.
This is definitely the hardest problem before you've done today, so it's okay if you're struggling with it. Yeah, maybe in this case. We're starting with, sorry. We're starting with atoms of carbon, and we're going to moles of carbon. Then we have to go to because we want the mass of C6H12. So we have to go to moles of C6H12 to grams of C6H12. Okay, so a lot of people forgot that middle step where you have to go from moles of carbon to moles of C6H12. That's the molar ratio step. Don't forget that, that's very important. So we're gonna start out with 9.2 times 10 to the 23rd carbon atoms. And we're gonna turn that into moles of carbon, which is 6.02 times 10 to the 23rd atoms per 1 mole of carbon. Sorry about that, M. What's our molar ratio? One mole of C6H12 over 6 moles of C. Oops, moles of C, because there are 6 moles of C for every C6H12. Our final step is you had to find the molar mass of C6H12, which is 84.16 grams per 1 mole of C6H12. We did that by multiplying the mass of carbon by 6, 12.01 by 6, plus 1.008 times 12. And you got an answer of 21 grams. All right, we have a worksheet, and I'm going to pass out tests.